Hello students and teacher Marco. In today's video, we're going to talk about circular linked lists. Our names are Isabela Cole Sarazo.
And my name, Jackson Andrés Vázquez Ramirez.
By the end of this video, you'll understand what they are, their main advantages, and some real-life examples of where they're used.
A circular linked list is a type of linked list where the last node points back to the first node, also known as the header or sentinel, creating a circular structure. Unlike a regular linked list that ends with null, a circular linked list loops back to the beginning, allowing continuous transversal through its elements.
Now that we know what it is, let's talk about the advantages and disadvantages of using this type of list. Advantages. Continuous traversal. Since the list is circular, you can move through the elements without stopping at the end. Efficient traversal. There's no need to check for the null pointers. Efficient insertion at the end. Adding a new node at the end doesn't require traversing the whole list if you keep track of the last node. Better memory usage. It avoids the need for extra sentinel nodes or repeat null checks. However, as with most data structures, there are also some disadvantages.
Disadvantages. Risk of infinite loops. If the stopping condition is not correctly managed, might never exit the loop. Linear transversal. You still have to go through elements one by one to reach a specific node. Checking if the list is empty can be tricky, since if it loops back during extra condition to detect an empty list. More complex direction removed nodes require careful pointer management to maintain the circular structure.
Main uses, examples in real life or in computing. Let's move on to some real life and computing examples to see how this data structure can actually be applied. Board games. Imagine a game where players take turns one after another in a loop. A circular linked list is perfect for keeping track of whose turn comes next, automatically turning to the first player when the last one finishes. A clock. A clock is another simple example. After 12 comes 1 again. The hours form a natural circular pattern, just like a circular list. Music and media players. In software, circular linked lists are often used in playlists. Each node represents a song, and when the playlist reaches the end, it loops back to the first song for continuous playback. They're also used in cache management algorithms, where each node represents a cache entry. When the list reaches the last element, it loops back to the beginning, allowing the replacement of old entries with new ones efficiently.
Graphical explanation of the insert at beginning method. We have an integer list of size 4, and we want to insert a new integer 10 at the beginning. First, a new node is created to store the number 10. Its next reference points to what was previously the head next node. Then, the head pointer is updated to reference this new node. Finally, the list size increased by 1. This is the final state of the list after the method executes.
Graphical explanation of the insert at the end method. Now we want to insert the integer 15 at the end of the list. We first create a pointer that stores the reference of the last node in the list, size -1. Then we create a new node that stores 15, make its next point reference the head, and update the last node's next pointer so it points to this new node. This ensures that the circular connection is maintained.
Graphical explanation of the insertarOrdenado method. First, the method checks if the list is empty. In this example, the list contains the integer 2, and we want to insert the integer 1 in order. We created two pointers, y, which point to the head, and x, which point to the node after the head. Then, the method starts a loop that compares the new value with x value. If the new value is smaller, the loop stops. If it's larger, both pointers move forwards until x reach the head again, or a greater value is found. At that point, a new node is created. Y's next pointer is updated to reference the new node, and the new node's Next pointer reference X. In this case, the head no points to 1 and 1 points to 2. Finally, the list size increases by 1.
Graphical explanation of the remove method. We want to remove the element at the position 0 from the integer list. A pointer stores the node we want to remove so that its value can be returned later. Then we make the previous node point to the node that follows the one being removed. In this case, the head now points to the node containing 2. Because the removed node is no longer referenced, Java's garbage collector frees its memory. Finally, the list size decreases by 1.
Explanation of the insert list method we created. We have two lists, and we want to insert one into the other at a specific position. We create a pointer called start, which points to the node just before the position where the second list will be inserted, and another pointer called end, which points to the node that will follow the inserted list. Next, we make a start point to the head of the second list, and then make the last node of the second list point to the end. The list size increases with the size of the inserted list. If the first list is empty, the head of the first list becomes the head of the second one, and the last node of the second list connects back to the head, maintaining the circular structure.
Conclusions. How easy it was to understand your methods. It was easy to understand, although it could be a bit confusing at first because it only has a next link and not previous one. However, as with any linked list, the key is to ensure that all pointers are correctly connected. Once you understand how the nodes link together, the rest of the operations become much easier to manage.
Is it better than a simple linked list? Yes. In some cases, it is better because it improves efficiency when inserting at the end of the list using the head pointer. This circular structure allows continuous traversal without needing of check for the end of the list, making certain operation faster and more efficient.
And that's it for today's video. I hope you now have a clear idea of what a circular linked list is and how it works. Thanks for watching.